A hot plate of electrical oven connected to a 220-volt line has two resistance coil A and B, each of 24 ohm resistance, which may be connected separately, in series or in parallel. So there are three different cases: separately, series, and in parallel. What are the current in the three cases? So what is that they're exactly asking? Simple. You have a 24 ohm resistance. If you connect it separately, that is individually, if you connect, there are two of them, remember. If you connect them in parallel or in series, what is the current in each of it? It's quite simple, straightforward, Ohm's law. So I'll show you the lengthy version of the calculation. You guys can do it in a shorter way. I'll show you how later. So single resistance, right, when we connect. So case one, we have the single resistance connected to the source. So for that, we, again, to find the current, we'll use Ohm's law. So we know V, that is 220. We know R, that is 24. And now it's just a matter of calculate. So this is I is equal to 110 by 12. Okay, you can divide with 4 actually, 55 by 6. Okay, that I can't further reduce, 55 by 6. This we need to divide. So 6, 6, no, 9s are right, 54, 1. So 1 is what? 1s again, that will be 10 now, 6, 4, 6, 6. So 9.17 ampere. That's your current. Now the case 2, A and B are in series. So in series, what happens? The effective resistance will be 24 plus 24 is 48 ohm. Next, post this is your finding the current, which is V by R effective, right? So this will be 220 by 48. So we already know 220 by 24. So we can do a smart thing. 220 by 48, we can write it as 24 into 1 by 2. So 220 by 24 is 9.17 divided by 2. So 4.5. Then what is this? 8. Or actually, it will be approximately 9. Approximate. So many amp. That's all. Case 3, A and B are in parallel. So the effective resistance over here is 1 by 24. That's 1 by 24. That's 2 by 24. That's 1 by 12 ohm. Not ohm, sorry. R effective is equal to 12 ohm. So the current is V by R effective again. So 220 by 12. But we know 220 by 24. So how do you relate this to? So help with that, we'll multiply and divide with 2. So 220 by 24 into 2. Right? So we have 220 by 24, that is I is equal to 9.17 into 2. This is 18.34 amp. So this is your answer. But I would like to do one thing, that is compare all of them. So when we have single, when we have it in parallel, and when we have it in series. So voltage is same, but the resistance is, say, this is 24, parallel it is 12, and it is 48. So as you can see, this is double, right? 48 is double of 24, and 12 is half of the single value. So whenever you connect anything in parallel, right, if the values are same, you have a pattern over here. I hope you guys understood the pattern. If you have two of them connected with the same value, it will reduce by half. If you have three of them connected, it will reduce by 1/3, so on and so forth. So current here it was 9.17. Here it reduced by half, right? So 9.17 by 2. Here it doubled. So again, obvious observation, but yes, that's how you can calculate faster if you get MCQ questions. Okay. Whenever you get same resistance, most of the time things are quite simple. So now you guys can pause and have a look.